This is Theo from Bonjour Solar. Today I'm going to show you a training about the lithium battery parallel connection diagram design. Now our off-grid solar system is going to be bigger and bigger because we need more and more capacity for the power. So that means we need more and more parallel for the lithium battery. So how can we make the design? How can we make the diagram of connection the best way can help our lithium battery to use the best use to use our capacity of the lithium battery. So today I'm going to show you a training technical. So here I prepare 3 ways of the connection in parallel. A is we make the parallel for all positive, and for the negative also we make all parallel them, and then we connect the first the number 1. We connect the for example number 1, number 2, number 3, number 4, number 5. We connect the inverter with the number 1 battery positive, and then we connect the negative of the number 1 battery negative. So some of the people, some of the engineer, they connect like this because this kind of connection, this kind of diagram it's a very easy connection, and then they can save many wires because here the connection in parallel they don't take many wires, and then only 1 wires from the inverter to the number 1 battery. So that means it seems that this connection you can save a lot of wires, you can save a lot of money. But is that okay for this connection diagram? Is this connection diagram can use your lithium battery very good? I don't think so. I think this kind of wire is no good. Because we can think about the resistance. For example, for the number 1 battery, we have only wires from the inverter to the number 1. So for example, if this wire is 1 meter, so that means we have only 1 meter wires resistance for the number 1 lithium battery. But you can also imagine for the number 5 lithium battery, we have not only these wires, we have this one. So that means that if the current, we need to the wires, it seems from here 1 meter. If every cable, every wire is 1 meter, that means for the number 5 lithium battery, we have a 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. From the inverter to the number 5 lithium battery, we have a 5 meters long cable, and that means 5 times of the resistance of the number 1 battery. So that means for the number 1 battery, they have a lower resistance, and the number 5 lithium battery, they have a higher resistance. Okay, so when we're charging the battery, because 1, 2, 3, 4, 5, if we parallel the lithium battery, the whole battery, we can think them, we can make it like a pack. That means that they are whole battery. So the voltage of both positive, negative will be the same because they are in parallel. The voltage is the same. But there is a problem of the current sharing. Okay, the current sharing. That means even they are the same voltage, the current, when they're charging the battery, most of the currents they will charge. That means that the number 1 is the lowest resistance. That means they have more current charging sharing to the number 1 battery. And the number 5 is the highest resistance. That means they have the least. They don't have many current sharing to the number 5. So once the number 1 battery is full, because they are lithium battery, once number 1 is full, the voltage of the whole pack, for example, the voltage of the whole pack will be 58.4, for example. Number 1 is full, but number 5 is not full yet. But now the voltage of the battery is 58.4 volts, maybe 57, 6, 15, 6. And then the battery will give the inverter, the charger, a signal that our battery are full, so no need to charge. So they stop the charging. For number 1, 100 full. Maybe number 2, 95% full. Maybe number 3, 90. Maybe number 4, 85. Maybe number 5, 80%. Now this is an example, to let you know more clear. So the inverter, the charger, not charge anymore for this battery. Okay, now this is the charging. And then, okay, once the inverter, they need to use the power, AC, the inverter will discharge the battery, right? The battery, they need to discharge. So once they discharge, because they also the same pack, they are in parallel. So once they discharge, the number 5 have only 80%. So once you all discharge the number 5 battery, the voltage of the number 5 is very low. The number 5 battery will give a signal to the lithium battery, to the inverter, to tell the inverter, now I am off. I don't have enough capacity. I don't have any capacity more. So you need to stop. You cannot discharge anymore. So the inverter will stop discharging. So that means this one, the number 5 may be 0, but the number 1, they still have about number 20%. So this is only an example to let you know. So that means the battery is not balanced. And this is for one-time charging and discharging. So you can imagine, if every day they charging, discharging like this, in few months later, the number 5 battery, the capacity will be very, very low, and then they always discharge, and sometimes the number 5 maybe is over discharging. So that will be not good for not only number 5, but also the whole system, whole lithium battery. You cannot use the 100% of the lithium battery, the capacity. So I don't think that this is a good parallel connection. I don't suggest you, whatever situation of your installation, I don't suggest you to use this kind of installation. This kind of installation is no good. You cannot use this kind of installation parallel. Maybe few months, no problem, but maybe 1 year, 2 years later, you will find the problem of the number 5. Always the problem with the last battery. Always the last one. So this is no good for the installation parallel. Okay, and then we will see the B. If we connect the positive here and the negative here, it seems the wire between each battery is the same. But there is also a problem. The problem is when you make the installation, for example, now we have only 5 pieces lithium battery in parallel. But when you make the installation, maybe the battery, they are bigger. And then they need to have some distance. So if we make like this, we connect the inverter positive here and the negative here. It is difficult to make the wire from positive and the negative, they are the same length. Very difficult. So this one, I don't suggest you to make like this. For me, my suggestion is use bus bar. If you use a bus bar, for example, here, positive bus bar, here, negative bus bar. And then all of the battery, most of the battery suppliers, they will give you a 1 meter long, for example, they will give you a 1 meter long cable wires, positive and negative, red color and black color. So you can make the bus bars in the middle, and then connect all the positive from the battery to the bus bars. They use the same longs wires, because all they use the 1 meter long cable. So the cable, the longs, they are the same. And then from the positive and negative bus bar, you can add one more air breaker, and then to combine the wire together. So okay, so now here I make an example for you. So you can see here, so we have a 1, 2, 3, 4, 5 lithium battery in parallel. So this is our bus bars, red color positive, and this is our bus bars, black color positive. And then you can see the wires from the bus bar to the positive of the battery. They are all the same longs. That means they have the same resistance. Here also, they have all the same longs of the positive. So like this. And then that means they can very good sharing, the current sharing. They can have the same current sharing for each lithium battery. So they don't have a so-called number 1, number 2, number 3, number 5, number 4. No, they share the same. Okay, and for the negative also. And once we combine together the wires from the bus bar, we have a bigger wires here, and then we connect the air breaker. This is for the safety, for the combiner currents together. And then we can control also the off and on, and protect the system. And then from this side, we connect the inverter. So according to my experience, this is the best way for the lithium battery parallel connection. And then we'll make your lithium battery, every of your lithium battery, the same current sharing, no difference. So if your system in parallel have some problem with the last lithium battery, you should think about the parallel connection. You should think about, is that the cable are not the same longs? Can the system sharing the currents the same? You need to think about that. So remember, bus bars is very important, very good for your system. And the longs of each wires should be the same, so they have the same resistance. Okay, thank you today, and this is Leo from Bonjour Shala. Thank you so much, and I hope this training can help you something. So see you next time. Thank you. Bye.